Hi, carrying on with reactions of metals with water, let me show you what we've got so far. Now, first we did lithium, metal and water, and we got lithium hydroxide and hydrogen. I showed you that on the board. And we balanced it up. See the blue 2s. And then we did sodium. Now that's reaction 2 there on the board. Very vigorous reaction. Sodium, metal and water will make sodium hydroxide solution. That's the alkali. That there is alkali. That is alkali. So the sodium hydroxide is an alkali when we use sodium. So when we use sodium, we make sodium hydroxide, but can you see a similarity? And then the third reaction, the one that burned with a lilac flame, potassium metal, violent reaction, potassium metal and water makes potassium hydroxide solution and hydrogen gas. And there's the balanced equation for that. So I want you to see a similarity between all three. And the similarity is this, the pattern. The pattern to see is, if the metal is reactive enough, reactive metal, plus water, in red, can you see that in red? Reactive metal and water will make metal hydroxide solution and hydrogen gas. Now, that is the pattern. The pattern to learn with water is when metals react, they react in that general equation way. And it is this general equation way that I want you to learn, and then chemistry doesn't come across as being a load of unrelated facts. It becomes patterns. So carrying on with that theme, I want to try and react water with a famous metal called magnesium. Remember magnesium? You may have come across it in general science. It's the metal that burns with a bright white light, and it's so bright that you can't look at it directly. You have to kind of look away or look at it through blue glass, etc., to reduce the amount of light that goes in your delicate eyes. Here I've got water, tap water, and here I've got some magnesium ribbon. Hope you can see that magnesium ribbon. Pieces of magnesium, and if I put those in there, and look, and show you, when we're looking for reactions, there's quite a lot of magnesium there at the bottom. When we're looking for these reactions, we're looking for bubbles. Can you see any bubbles? The bubbles will be bubbles of hydrogen gas. And I can't see any. So does that mean there's no reaction? Maybe. But it could also mean that the reaction is very, very, very slow. So I'd like to do a little experiment. I've taken a funnel, which I've broken the end off, short spout funnel. What if I hold this over all of those pieces? Those pieces of magnesium now are underneath that funnel. Perhaps I need a bit more water. I put more water in, top that up a bit with water. I'm going to get a test tube, an empty test tube, and I'm going to fill it with tap water. And having filled it with tap water, I'm going to put my finger over the top. With my finger over that's got tap water inside it, finger over the top. If I invert it and get it over the spout. Now, I want to leave that. I want to leave that for about a week. And what I want to see, I want to see the bubbles. You can perhaps see the odd bubble forming now on the magnesium. But over a period of about a week, any bubbles given off will be funneled up the short spout that's broken on the funnel and into my test tube of water. And as the bubbles of hydrogen go in here, they'll push the water out. After about a week, I should be able to prove I've got hydrogen by testing the gas in the test tube and proving it is indeed hydrogen gas with the squeaky pop test. So I'm going to just put that to one side, and perhaps in a future video I will come back and show you that the gas collector does give me a squeaky pop. So that's showing that the reaction with magnesium and water is very slow. The reaction is too slow for doing anything in the period. Leave it a week and then we will have enough reaction for us to test with a lighter spring and get a squeaky pop. So what I want you to see is that when you have this magnesium and water making metal hydroxide and hydrogen gas, that's the hydrogen gas. When I'm wittering on about hydrogen gas being made, it's because of that general equation. So what will happen when you've got magnesium and cold water? Well, magnesium and cold water, if I do it on the board for you, my marker pen somewhere, there it is. So, the general equation is magnesium, reactive metal. So if the metal is reactive enough, reactive metal plus, let's write cold water, will make metal hydroxide solution plus hydrogen gas. So, with magnesium, we can write a word equation that is specific to magnesium, not a general equation like that one is, but I'm going to use the general equation to do it. So magnesium is the reactive metal, magnesium is a solid, cold water is H2O, it's a liquid, L, and it will make metal hydroxide is magnesium, OH twice into the formula, AQ for dissolving water, and hydrogen gas. Actually, I've got that wrong because I've tried to say it's a word equation. Look, word equation. And it's not, is it? That's not a word equation. That is what we call, that is called a symbol equation. Symbol equation. The word equation would be magnesium, metal, plus water makes magnesium hydroxide and hydrogen gas. So that now is the word equation. Look, it involves words. So word equations involve words, and symbol equation, that's a symbol equation, and general equation. Tells you generally what's going to happen. Now, what you need to do is to balance the simple equations that we have. So there's one magnesium, two hydrogens. You know, you've got four hydrogens, so you need a two there. Two oxygens. That's now balanced. So you need the red big 2 to balance the simple equation. Underneath it is the word equation. Learn the general equation on top. And from the top general equation, I want you to be able to write the specific word equation or symbol equation, whatever we need at the various tasks that you're asked to do on exam papers. Right. So let's put you back and get it round that way. Because, as I've shown you here, actually you can see the bubbles now. The bubbles are starting to form. Actually, if I show you the next demonstration, then we can come back. Can you see? You might be able to see bubbles. There are bubbles rising up in that funnel, rising up from the pieces of magnesium that are trapped underneath the funnel. See those bubbles? And they are collecting into a sizable bubble here where my little finger is. We'll come back and have a look at those in a minute after this next demonstration. So the reaction with cold water is very slow. Do you think it'll be any different if we use hot water? And not just hot water, but the hottest type of water we can get. What about steam? What if we try and react magnesium with steam? Well, then the reaction becomes a fast one. And the apparatus we need to react it is this one. Now, I want you to understand here, I've got, where my finger is here, that is magnesium. Magnesium metal. I'm going to try and grab it a bit further along here. So, magnesium metal. This is ceramic wool at the end. And what we do is we dampen the ceramic wool to keep some water. So there's some water there held by the wool, ceramic wool, that's why we're using it. Magnesium here. There's a tube on the end, a delivery tube, where if there's a reaction, then any gas will be forced to come out of here. And if it's hydrogen gas, I should be able to light it. Well, we'll see. Put that Bunsen burner to one side for a minute. I just need to get steam. And how am I going to get steam? Well, I'm going to get the steam by putting a roaring flame on this bit here, on the ceramic wool. When the water starts to boil, then I'm going to get the magnesium hot as well at the same time. So I've got two Bunsen burners here. I'm going to get the magnesium hot. Only when the magnesium's hot will it react with the steam. So it's a bit damp at the moment. Let's get rid of the dampness. Right, so now the magnesium is dry. Now I'm going to get this part of the test tube really hot. And when it's really, really hot, I'll know it's hot because the tube underneath will glow orangey red. That's the glass. And then I'm going to use this burner to make steam. Steam will then react. Can you see steam coming out the end? Oh, it's getting a bit damp. I don't like it damp. Let's get it really hot. Come on. Magnesium is simply not hot enough because the drops of water are cooling it down. Right, now it's going there. Now I'm going to generate the steam. The steam will react with the magnesium. Rapid reaction, that is hydrogen burning at the end in a jet. And now there's no more steam coming out the end. I'll turn my Bunsen burners off. I can get a heat-proof mat. Heat-proof mat here. I can break the test tube, and you can see there, let me come around and show you. You can see there, I switch it around. You can see that this contents here, these are little pieces of white ash. The white ash is magnesium oxide. So the white ash is magnesium oxide. You've seen that before. You know when magnesium burns with a bright white light, it leaves a white ash. Well, that's that white ash. That was the ceramic wool. That there is the ceramic wool end, and that reaction, maybe I can show it to you on the board, that reaction is different to the one with cold water. So what happens with steam is, with steam, magnesium plus steam made magnesium oxide solid, and the gas you saw me burning at the end was hydrogen gas. That is the specific reaction going on, and if you want the balanced equation for it, then we turn the words into symbols. Magnesium was a solid, steam, H2O, is a gas, and this reaction you get the oxide with steam, not the hydroxide. You get the hydroxide with cold water, but with steam you get the magnesium oxide, which is MgO, and it's a solid, and the hydrogen gas is H2 gas. Check it's balanced, one magnesium or one magnesium, two hydrogens, one oxygen, that is balanced. So I want you to know that there's a fundamentally different reaction that happens when we have steam reacting with metals. When steam reacts with metals, you get oxides. When water, liquid water, we say cold water, but we mean liquid water. When liquid water reacts with metals, you get metal hydroxide. So you've got to remember these general equations. There's two general equations. One with cold water and one with steam, and learn them both so that if we ask you to react things with cold water, you make metal hydroxides and hydrogen gas, and if we ask you to react things with steam, then you know you're going to get the metal oxide and hydrogen gas. Okay, we'll stop it there. This stopper doesn't seem to work so well now. So let me just reach across